Okay, what we're going to talk about now, we are going to talk about your molecular shapes, okay? So in this case, it says construct each of the following molecules and predict which has a linear molecular structure. So remember, linear means that it's got basically equal pulling, right? And so by linear, it means that all of the molecules are in a line. So if I'm looking at this problem here, so we've got CH4. Alright, when we look at CH4, you know that carbon's got 1, 2, 3, 4 valence electrons, right? So if we go back to the periodic table, C4 is the group 4 valence electrons. And each hydrogen is going to share 1. So each hydrogen, remember, H has just 1 because it's in group 1. Yeah, where's group 1? Group 1. Okay? So it's going to share like this because, again, it's a covalent compound, right? And so now everybody has, each hydrogen has 2, and carbon has a total of 8. So that structure, when we put it together, that structure is going to look like this, okay? So do you see how none of these none of these molecules are in a line? So if I set that down like that, you can see you've got one coming out, and then several of these are going down into the table. So this shape right here, this is not a linear shape, all right? The next one we're going to look at is CO2. Well, we know that carbon has 1, 2, 3, 4, okay, and each oxygen has 6. So let me put these oxygens in here, 2, 3, 4, 1, 2, 3, 4, 5, and 6. And the second oxygen, 1, 2, 3, 4, and there's an extra. So carbon, they're sharing here and they're sharing here, but this oxygen needs one more, right? This oxygen needs one more, and this carbon needs to have 2 more bonds, right? Because right now this oxygen has 1, 2, 3, 4, 5, 6, and the one is sharing to 7, and this one has 1, 2, 3, 4, 5, 6, and the one is sharing. So these electrons are going to come in here, and this electron is going to come in here and here, and so this one is going to look like this. Okay, so you got the 2 lone pairs. Remember, any of these electrons, oxygen is always going to have lone pairs of electrons. It's always going to have 2 lone pairs. Your carbon doesn't want to have any. So now if you look, carbon's got a total of 1, 2, 3, 4, 5, 6, 7, 8, right? And each oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So 2 lone pairs of electrons and then 2 pairs bonding. So when we make this right here, and y'all remember this is called a double bond, right? So it's going to look like this. Okay? And so when we make that, your structure, you can see it looks like this. So if you notice, all of these atoms are in a straight line. So in this case, your shape here is linear. Okay? So to answer this question, right, the question asks which one is going to be linear, and of course it's CO2. But let's look at these other shapes here let's look at NH3. Okay. If we look at NH3, we know that nitrogen is in group 15. So it's got 1, 2, 3, 4, 5 valence electrons. Move that up so you can see it. Right? There's nitrogen, 5 valence electrons. And each hydrogen we've talked has 1, right? So this compound, again, is covalent. And it's going to look like this. So if I draw this with the bonds put in there, we still have a lone pair of electrons. This is a bond, this is a bond, and this is a bond. Remember, 2 electrons constitutes a bond, right? These are your lone pairs of electrons. So when I look at this shape right here, okay, you can see up top, right up here, this would be where those lone pairs of electrons are. And because electrons are negative, they're going to push apart. And so as they push apart, they push these bonds down. And so this shape, you can see, is not flat. It sits, you can see that if it was to sit flat, it won't sit flat, okay? It's kind of a pyramidal. This is what we call trigonal pyramidal, okay? And water, we also know has, so this is going to be your oxygen has 1, 2, 3, 4, 5, 6, right? Valence electrons. Each hydrogen has 1, so it's going to share 1 here and 1 here, right? So you might think that this shape is linear. However, when you look at it, what you'll notice is this isn't in a line, okay? And that's because of these two lone pairs of electrons you see there. You've got a lone pair here, and you've got another lone pair over here, and these are repelling against each other. So these bonds, instead of being straight out like this, it actually pushes this bond down, and so this shape is what we call bent. Okay, and you can see that this is bent. It's not straight. It's not linear like your CO2 molecule was. You see the difference? Okay. All right. So your answer choice here was B. Okay, your CO2 molecule. All right. So, and this one, the shape linear, also talks about the polarity, right? This will be a polar compound. I mean, sorry, a nonpolar compound because it's equal sharing. This one would be a polar compound. Water would also be a polar compound because typically when you have these lone pairs of electrons, you're going to have some polarity. The shape will tell you that. All right. And the next one we need to look at. Okay. It says the following picture shows a covalent molecule. Okay. So first thing you know, it says covalent. So what's key to know is we can automatically cross out that compound right there because Na and is a metal. This is a nonmetal. That would be an ionic compound. So now we're just dealing with these examples right here. So it says which one has the same shape as below. Well, if I go to build these, right? If you go and you build H2O2, all right, the shape that you would get is going to look like this. Okay? So this is the shape you would get. The reason you get this shape, if we go back to and look at how this is constructed. Okay. The paper's messed up. Alright, so I've got your oxygen that has 1, 2, 3, 4, 5, 6, right? Valence electrons. You have another oxygen with 1, 2, 3, 4, 5, 6. So these two are going to bond together, and then you have a hydrogen which has 1 and another hydrogen which has 1. And so in order to stick these together, you're going to put these two together here. So they're going to share these electrons, and then this is going to share one here, and it's going to share one here. So that your structure essentially is going to look like this. Okay? And so that's what this structure here is. So this structure, okay, because the oxygens have those lone pairs, is very different than the one depicted here. Okay? So automatically we know this answer is wrong. Now, we just talked about NH3, okay? So if you want to rewind back, you can see that. But remember, up top here, we have a lone pair of electrons. This one shows that there are equal bonds. These bonds right here, although it kind of looks the same, it's not, because you got to remember up top here is another whole basically a cloud of electrons. So this answer choice is wrong. Now when we look at BH3, with BH3, boron is an exception, and it only wants to have 6 electrons. And so what we're looking at here, and you can see this molecule is very, very flat, okay, which is exactly what they're showing here. And if we go to look at the Lewis dot of this, okay, you have boron, which has 1, 2, 3 electrons, and then we take each hydrogen and we put it next to it. Okay, and so this structure is going to be what we call trigonal planar, because you see how all of these are in the same, all of these atoms right here, they're all in the same plane. Okay, all right, and that will do it for your shapes.